Go ahead, Houston.
Charlie, the plan here is that at about 2 hours, 50 minutes MET, we'll do another burn, probably around 15 feet per second to circ up.
Okay, John, we copy that. 15 feet per second about at about 250 MET.
Good copy.
Adios. This is space. Yeah. This is the ground.
Atlantis, Houston, in the blind, need the back panel configured for TDRS, panel command, best antenna. Atlantis, Houston, com check. Atlantis, Houston, com check.
Houston, Atlantis, loud and clear.
Okay, we've got you loud and clear also. Atlantis, Houston, we need upper right forward antenna.
This is Mission Control. Houston, Atlantis, currently passing south of Australia as it moves toward completion of its first orbit of Earth. On board, the crew is continuing to prepare for their stay on orbit. The next major event will be to open Atlantis' payload bay doors. Also, the computers on board are being switched from the software used for ascent and insertion into orbit to the software that's used for orbit operations. Again, engine firing of the orbital maneuvering system engines on Atlantis, normal planned firing to circularize the spacecraft's orbit at 160 nautical miles went very well. Atlantis currently is in an orbit of 160 nautical miles high by 154 nautical miles high. Second burn, a very slight burn of about 13 feet per second, actually about 9 miles an hour. Change in velocity for Atlantis will be required a little later on in the flight, about 3 hours into the flight, to tweak the orbit and make sure that it is exactly at 160 nautical miles circular for requirements of the atmospheric laboratory applications payload.
Yeah, you probably saw we got a APU Spec 86 message. We looked at it. We don't see anything too unusual there, do y'all?
Okay, we'll take a look at that. And Atlantis, we lost her for a while on comm. Can you tell us what you did, if you did a panel command, and what your configuration is now?
Okay, yeah, when we came up in Ops 2, the GPC selected antenna was the lower left aft, and it had a down arrow next to it. We had no comm with you, so we manually selected around until we got to the upper right aft, which was the first place that we contacted you, and we are now in the upper right forward position. We never did a panel command. Houston, Atlantis, did you copy that?
Roger, we copied that, and we think we lost you because the BFS went down prior to locking up on TDRS.
Okay, would you like us to switch back over to GPC for you?
Stand by one. Atlantis, Houston.
Go ahead, Houston.
Roger, we concur on your Spec 86 message. That's no action for you. nominal for going into Ops 2. After you've completed Step 9 and SM has control of the payload buses, you can go back to auto or GPC on the antenna.
Okay, John, we copy that.
This is Mission Control Houston. Again, all systems on Atlantis functioning very well. The crew is going through procedures to get ready for their stay on orbit and their work with the Atmospheric Laboratory for Applications in Science. The next major event will be opening of the payload bay doors. Also, Atlantis will have a slight engine firing at about 3 hours into the flight to fine-tune their orbit at 160 nautical miles circular. 4 observations that will be done with the Atmospheric Laboratory for Applications in Science.
Houston, Atlantis.
Go ahead, Atlantis.
Yeah, John, we're ready to take the BFS to standby. I just want to make sure that Inco or no one has any problem with it.
Charlie, you have a go for that.
Okay, thank you.
Atlantis, Houston.
Go ahead, Houston.
Roger, Charlie. We'd like to confirm that you have done the TIFL load, Step 9.
Okay, and David says it's just completed. And I've got a question for you, John. We're still showing the SM machine not controlling the payload buses.
Okay, we'll look at that. Atlantis, Houston, we've confirmed that the SM machine does have control of the payload buses. You can go to GPC on the antenna, and you have a go to maneuver to the payload bay door attitude.
Okay, we just started, and we're going to GPC on the antenna.
John?
Houston, Atlantis.
Go ahead, Atlantis.
Yeah, John, can you check with DPS and see if we have a go for the airlog resets to GNC and SM?
You have a go, Charlie.
Okay. And John, if ECOM's ready, we're going to put with red activation.
Okay, Charlie, we're ready and watching.
Houston, Atlantis, red activation is complete, and we're standing by for a go for the payload bay doors.
Roger, stand by. Atlantis, Charlie, you have a go for payload bay door opening.
Okay, copy. Go for payload bay door opening.
This is Mission Control Houston. Atlantis continuing in its first orbit of Earth. Shortly it will be crossing the central Mexican coast, moving up the midwestern United States across the Great Lakes as it completes its first orbit. On board, the crew just received a go to open the payload bay doors, the first process in setting up camp on orbit. Everything has proceeded normally throughout the flight so far, and flight controllers are now watching over the shoulder of the crew as they work on opening of the payload bay doors. Atlantis has maneuvered to the proper position for payload bay door opening, in other words with the payload bay facing toward Earth, and with the nose pointed toward the south.
And Houston, Atlantis, we're into the payload bay door opening procedure.
Okay, Atlantis, we copy that and we're watching.
This is Mission Control Houston. Mechanical Systems Officer here reports he sees the crew opening the latches on the payload bay doors. Well into the procedures to open those doors. Atlantis currently passing above the central United States.
This is reading left.
Atlantis, Houston, you have a go for orbit ops.
All right, John, we thank you. Go for orbit ops.
Atlantis, Houston, with you on Tetris East.
Okay, John, we read you loud and clear. House.
Okay, you're 5 by.
Ground.
Atlantis, Houston for Charlie.
Go ahead, John.
Charlie, we're getting ready to hand over
Go
to
ahead.
the Orbit 2 team, and I just want to tell you for the Ascent team that we sure enjoyed working with you, and y'all are off to a good start on your mission to study the Earth's atmosphere. We wish you all the best for the next 9 days.
Hey, John, thank you guys very much for the support job getting us up here, and you might call over to the office and make sure that Brandon Stan knows that the speed bump is out of the way.
Okay, I'll tell him that, and have a good flight.
Talk to you later.
On
Houston, Atlantis for the ECOM.
Go ahead, Charlie.
Okay, we show the radar temps looking good. We're in block 10 of the post-insertion, post-payload bay door ops rad config, and want to know if they're go for the high-load evap to off.
Charlie, you're go for that.
This is Mission Control, Houston. We're just under 2 hours into the flight of Atlantis on the Atmospheric Laboratory for Applications in Science mission. Atlantis is presently passing over Italy on the
Houston,
second
Atlantis,
orbit.
for GNC.
Go ahead.
Okay, yeah, if you could just tell them Star Tracker self-test and door opening is complete. We had both failed self-tests the first time around. On the second pass, the minus Z was good, minus Y is still failed as expected, and we had dual motor time.
Okay, Charlie, we copy that, and we'll be looking at why the minus Z failed the first time.
The crew aboard Atlantis is presently stepping through the final procedures in their post-insertion timeline. That's the procedures that are handled by the crew members after the launch phase. Commander Charlie Bolden just radioing down that the star trackers are activated. Those are used to help in tracking stars and aligning the inertial measurement unit platform aboard the orbiter. The Orbit 2 team now on station here in Mission Control under direction of Flight Director Rob Kelso. The Orbit 2 team will have control of the flight in terms of the orbiter Atlantis for the next 8 hours or so. The next procedure that will be undertaken aboard the vehicle is the activation of the Space Lab hardware in the aft portion of Atlantis's payload bay. The payload bay doors have been opened. The crew's been given a go for orbit operations, and all is well aboard the vehicle. Crew member Kathy Sullivan, Mission Specialist number 1, will be performing all of the steps in the Space Lab activation procedures. In the timeline, those procedures are scheduled to begin in about 10 minutes. The crew is about 5 minutes behind the timeline at this point. There's no concerns, obviously, with that. The crew can easily catch up on their timeline. The activation usually takes about 2 hours, and at that point, the crew members on the blue team, especially the payload specialist Dirk Frimout and Kathy Sullivan, Mission Specialist 1, will begin performing all of the Space Lab activities related to the Atlas mission. During the handover from the Ascent team, Atlantis has no vehicle problems being tracked at all. Very clean vehicle, very clean ascent. Just after ascent, it was detected that there was a slight underspeed of about 6 feet per second. That is attributed somewhat to the main propulsion system dump. That's a dump of residual propellant that's always done after the vehicle gets on orbit. So that's no concern at all. It will require a slight orbital maneuvering system burn in about a little less than an hour, and that burn's going to be about 13 feet per second. So a very, very small burn that will fine-tune Atlantis' orbit at about 160 nautical miles. That slight underspeed is something that happens on quite a number of shuttle missions, and there's no concern at all about that. It just requires a fine-tuning for this particular payload for the instruments aboard the Atlas pallet in the rear of Atlantis' payload bay. So that will be conducted in a little less than an hour, and will fine-tune the orbit at about 160 nautical miles. So once the crew completes the post-insertion timeline, Kathy Sullivan can then step into the Space Lab activation procedures again. That's upcoming in about 10 to 15 minutes. Atlantis is currently circling the Earth at about 160 nautical miles by 154 nautical miles, and takes the orbiter about an hour and 30 minutes to circle the Earth at this point. Atlantis is currently passing just to the west of the Red Sea. And again, this is the second orbit of the mission. We're 2 hours and 5 minutes into the flight, standing by for the crew to be given the go to begin the Space Lab activation procedures. This is Mission Control, Houston.
Atlantis, Houston for Charlie with some words on your underspeed and changes to your timeline.
Okay, Jeff, stand by one. Okay, Jeff, we're ready to copy.
Okay, Charlie, due to your underspeed, we're going to require an OHMS 3 burn. What we'd like to do is do a little bit of rescheduling as follows. We'd like you to do the IMU and COASCAL on time, and then ASAP maneuver to the OHMS 3 attitude in the B1 Pri DAP, and the burn will be at about 2 hours, 50 minutes. Then you'll maneuver to the water dump attitude as soon as possible post-burn. We'd like you to begin the waste dump procedure at an MET of 3 hours, 5 minutes, and the dump duration will be approximately 30 minutes. You can perform the SM checkpoint, the Group B power down, the lamp test, and the smoke detection test during the water dump. You can move the KU antenna deploy at any time that's convenient to you post the OHMS burn. We think you should be able to get back onto the nominal timeline by an MET of 4 hours.
Okay, Jeff, we copy all that, do the MECO underspeed, OHMS 3, and you want us to do, follow the following schedule, IMU and COAS on time, ASAP following that, go B1 Pri for the water dump, ASAP burn, and we're going to do the waste dump at approximately MET 305, should last about 30 minutes, SM checkpoint, Group B, lamp test, and smoke detection during the water dump. I'll copy.
That's good, Charlie, and there won't be any change to the timeline for the payload activation.
Okay, that was our next question. You read our mind. Thank you. And Jeff, would you advise us to go for vernier ops?
Your go for that, Charlie.
Capcom Pete Weissoff radioing up to Commander Charlie Bolden, all the updates to the crew's timeline, some of the changes that will occur in the next couple of hours. The one change that will not occur, will not happen, is that the crew will stay on the timeline for the activation procedures for the Atlas payload. So from that standpoint, that's good news. They'll stay on that, and they will do a small orbital maneuvering system burn at 2 hours and 50 minutes. That's about 42 minutes from now. That will fine-tune Atlantis' orbit for the so that it can support the Atlas observations.
Atlantis, Houston with some words on teleprinter.
Okay, Houston, go ahead.
Yeah, Charlie, we just wanted you to give us a heads up when it's activated so we can get our test message on board.
Okay, we copy. We'll hustle on the teleprinter.
This is Space Lab Mission Operations Control in Huntsville. Following launch, members of the Science Activities team here in Huntsville began the process of going through the Atlas I Science Activities timeline to identify which experiment operations will need to be adjusted due to today's launch occurring about 13 minutes after opening of the launch window. That time change will mean that Atlantis will be entering the Earth's shadow and coming out of the shadow about a minute and 1/2 earlier than per the pre-launch timeline. Since some of the science experiments are scheduled around the spacecraft's passage through orbital sunrise and sunset, there was a need to replan those activities and factor in the relatively small changes from the pre-planned timeline. So that process is currently underway. Looking ahead, once Space Lab activation is completed and the small trim burn has been accomplished, we'll be having an approximately 30-minute long procedure known as payload activation, which consists mainly of configuring power supply switches and circuit breakers for several of the Atlas I experiment systems. Some of those steps will be executed manually by the crew and some by commands from the Space Lab experiment computer. Following that set of procedures, initial operations with some of the Atlas I scientific experiments are scheduled to begin at about 4 hours 15 minutes mission elapsed time, or around 11:30 a.m. Central Daylight Time. Now at 2 hours 13 minutes mission elapsed time, this is Space Lab Mission Operations Control in Huntsville.
Atlantis Houston, we're about a minute and a half from an LOS. We'll pick you up on the other side at 2:27.
Okay, copy, Jeff. 227.
Good job.
This is Mission Control Houston. Atlantis has passed out of range of the NASA Communications Satellite Network. We'll reacquire the signal with Atlantis and crew in about 7.5 minutes.
Atlantis Houston, back with you.
Houston, Atlantis, line clear, and a couple items for you, Jeff. We show teleprinter activation complete, and we commenced Space Lab activation just about 10 minutes down on the timeline. I'm currently holding before doing step 2 in block 1. Just wanted to make sure you guys were with us and we were go to proceed.
Stand by, Kathy. We're polling the room right now.
Standing by.
Atlantis Houston for Kathy, your go to continue with the Space Lab activation.
We copy. Go to continue lab activation.
Atlantis Houston, we're sending you orbiter state vector and PEG 7 targets.
We copy. Houston, new vectors. Houston, Atlantis for the lab folks. We show block 1 complete in the activation procedure, and we're going to load the TIFLs.
Copy that.
Mission Specialist Kathy Sullivan now going into the second block of the Space Lab activation. The first block being completed. That is just the initial power up, sending power from the orbiter back to the pallet assembly in the rear of Atlantis' payload bay, where the Atlas experiments are located.
Atlantis Houston with your OHMS 3 pad when you're ready to copy.
Okay, Jeff, stand by 1 on the burn pad, and we're going on to block 3 in the activation.
Copy that.
Kathy Sullivan has completed the second block. That's loading the Space Lab TIFLs, as they're called, TFLs, for telemetry form LOMAT. Telemetry format load.
Houston, Atlantis, Jeff, ready for the OHMS pad.
Okay, it'll be left ohms only. TV roll will be 180. Trim load, pitch minus 0.1. Left yaw plus 4.9. Right yaw minus 4.9. Weight 222059. TIG time 00/02:50:02.7. Peg 7's delta VX plus 012.5. Delta VY, all balls. Delta VZ plus 000.2. Burn attitude, roll 102. Pitch 315. Yaw 357. Delta V tote 012.5. Pigo 00:14. Vigo plus 011.79. Vigo Y plus 002.47. Vigo Z plus 003.36. HA 160. HP plus 159. Ohms gimbal check NA. RCS interconnect none. Down mode options none. Ohms helium reg test left. Ohms helium P vapor isols. A open, B closed. Over.
Okay, Jeff, yeah, you got stepped on by a couple of things. I'm going to need a couple of numbers from you. First of all, understand that this is left ohms only, is that correct?
That's affirmative.
Okay, and then if we can come on down to the PEG 7 targets, I missed the delta VX.
Okay, delta VX is plus 012.5.
Okay, I got that. And then over in the Vigos, if you just give me the Vigo Y.
Okay, Vigo Y is plus 002.47.
Okay, Jeff, and how about if I'll read back to you real quick here. It'll be left ohms, TV roll of 180. Trim is minus 0.1, plus 4.9, minus 4.9. A weight of 222.059. Take of 0 days, 2 hours, 50 minutes, 02.7 seconds. The delta VX is 12.5. Y is all balls. Z is plus 0.2. Attitude of 102.315.357. Delta V total of 12.5. Pigo of 14 seconds. And Vigo's X is 11.79. Y is 2.47. Z is 3.36. We'll end up at a 160 by 159. No gimbal check. No RCS interconnect, no down mode, and ohms helium reg test. We'll use the A open and the B closed.
That's affirmative, Brian. Good copy.
Okay, thanks a lot. At Houston, Atlantis.
Go ahead, Charlie.
Yeah, Jeff, for GNC, the IMU align was completed at 2 hours and 25 minutes. Want to know if they need the numbers.
Charlie, we can get the numbers ourselves. You don't need to read them to us.
Okay, the COAS Cal is completed. We had a delta X bias of 0.39er and showing a delta X bias of 0.11 in the verification. Do they want us to redo it? That was at 2 hours, 36 minutes, and 30 seconds.
Charlie, those numbers look good to us, and the IMU line look good to us, and we'd like you to go ahead and maneuver to the burn attitude.
Okay, and work.
Atlantis Commander Charlie Bolden radioing down that the navigation units, the inertial measurement units aboard Atlantis have been aligned, and he's been given a go to maneuver the orbiter to the orbital maneuvering system burn attitude. The numbers for that burn upcoming at 2 hours and 50 minutes. That's about 9 minutes from now. The burn will last about 14 seconds using only one of those orbital maneuvering system engines on the tail of Atlantis. That's using the left engine. and that burn will last for 14 seconds and change Atlantis' velocity by 12.5 feet per second. That will put Atlantis in a 160 by 159 nautical mile orbit. Once the maneuver is complete and the burn is complete, Atlantis will then be maneuvered to another attitude to support a water dump. Actually, that's from the waste tank aboard the vehicle, and that dump is scheduled to begin at 3 hours and 5 minutes, and that's about 25 minutes from now. That dump of the waste tank aboard Atlantis will last for about 30 minutes. While all of that's going on, Mission Specialist Kathy Sullivan is stepping through the Space Lab activation timeline. She's completed the telemetry format load. That was block 2. She's actually stepped through and now is in the process of completing block 6 of the Space Lab activation. Kathy Sullivan has completed the Space Lab subsystem command and data management system initial activation. The CDMS includes 3 identical computers aboard the vehicle. One of those computers is dedicated to the Space Lab experiments, one supports the Space Lab subsystems, and the third is used as a backup.
Houston Center.
Atlantis, Houston for Charlie. Atlantis, Houston in the blind. We're off the tail. Your go for the burn when you reach attitude. Atlantis, Houston, we're experiencing some Radicom off the tail. Your go for the burn on time once you're in attitude.
Okay, we copy, Jeff. Go for the burn on time. We're almost in the attitude.
Copy that.
About a minute and a half away now from the orbital maneuvering system burn. Guidance, Navigation, and Control Officer reports that Atlantis is in the proper attitude to support the burn. That burn will be about 14 seconds long and change Atlantis' velocity by 12.5 feet per second, raising the orbit to 160 by 159 nautical miles.
Houston, Atlantis.
Go ahead, Kathy.
We show lab activation complete on board, Jeff, all nominal.
Okay, copy that. Atlantis, Houston, we see good residuals, no trim required.
Okay, we copy that, Jeff.
The burn of the orbital maneuvering system engine aboard Atlantis has been completed. The vehicle is now in 160 by 159 nautical mile orbit. Flight Director Rob Kelso polling the room. Space Lab activation is complete aboard Atlantis. He's polling the room, making sure all of the flight controllers are comfortable with their systems as we prepare to deploy the KU band antenna used for television and transmission of data to the ground.
Atlantis, Houston with some switch throws on R1.
Okay, Jeff, go ahead.
Okay, we just have some cleanup steps from the post-insertion cryo config. We need the O2 and H2 tank 3 heaters, Alpha and Bravo, 4 switches to auto.
Okay, Jeff, that's complete.
Copy that.
And Houston, Atlantis, we're on our way to the water dump attitude.
Okay, copy that.
Good job.
Atlantis, Houston, and just a heads up, we're going to be doing an early handover to Tidris East in about 2.5 to 3 minutes.
Okay, Jeff, thanks a lot.
Atlantis and crew just crossing the equator to begin the 3rd orbit of the mission. New feature on this graphic on NASA Select is a yellow orbiter that highlights the position that Atlantis is maneuvering to. This is called a ghost orbiter. Atlantis is the dark background to the yellow foreground, and that is the position that Atlantis is maneuvering to, the attitude. That attitude will support the wastewater dump upcoming at about 3 hours and 5 minutes. That's about 8 minutes from now. Once in the proper attitude, the water dump can begin. That waste tank quantity right now stands at about 38%. It will be dumped down to the 5% level, and that dump will last for about 30 minutes. During that process, the Space Lab activation is wrapping up aboard Atlantis, and the orbiter crew, consisting of Commander Charlie Bolden and Brian Duffy, pilot, will continue getting the orbiter in the proper position and configuration to support the Space Lab experiments. That includes the wastewater dump that's upcoming in a few minutes, and also a smoke detection check of all of the systems aboard the vehicle, and also powering down some equipment that's not going to be necessary for the Space Lab part of the mission, thus hoping to conserve some of the consumables that help keep Atlantis up for the duration of the flight, the 8-day mission. A Group B power down, as it's known, is a simple procedure of powering down some equipment, including one of the 5 computers aboard the vehicle. Also putting one of the 3 inertial measurement units in a standby mode, as it's not required for navigation while the vehicle's on orbit. This procedure is very similar to turning off lights in portions of your home that you're not occupying as a means to conserve energy, and this is a normal procedure that's done on all Space Lab missions.
Atlantis, Houston, just a heads up, the Timbu is on board to lower the lower limit to 5% for the wastewater dump.
Okay, Jeff. Charlie just told me that he thinks he changed it to the limit to 6 already.
Okay, we copy that.
Houston, Atlantis.
Go ahead, Kathy.
Yeah, Jeff, told a little white lie on lab activation. I had one LED status on R7 just after payload cabin was powered on. We showed the subsystem, the experiment inverter cross-tie light to the subsystem. Let me try that again. The experiment AC bus cross-tie light to the subsystem inverter illuminated when we powered payload cabin to on. And before I commenced lab activation, I just threw the experiment cross-tie switch to the experiment inverter position with nothing else powered, and that, of course, reconfigured the relay. And that's the only discrepancy we observed during lab activation.
Okay, we copy that, Kathy. Atlantis, Houston, with some words on your DAP.
Go ahead, Jeff.
Charlie, we'd like you to load the A9 DAP, and once it's loaded, to go to A9 burns.
Okay, you want us in A9 burns right now? I'll go ahead and get it, Jeff.
Okay.
Houston, Atlantis.
Go ahead.
Yeah, Jeff, just wondered if the POC perhaps was doing some commanding. We just got a message on the DDS, orb, diag, slant, cache, 03.
Stand by. Atlantis, Houston, we see the nozzle temperatures are up near the limits. We're ready for you to continue the wastewater dump.
Okay, Jeff, put it in work.
Atlantis, Houston for Kathy.
Go ahead, Jeff.
Yeah, Kathy, there was no commanding to you. Apparently that message you received is due to the scrub error counter in SCOS. It happens occasionally. There's no problem. SCOS appears to be running fine. There's no action on your part.
Okay, thank you much.
Atlantis, Houston with some words concerning payload activation.
Go ahead, Jeff?
Yeah, Kathy, we wanted to know if the orbiter audio config block 9 was complete, in which case we'll get ready to hand you over to Marshall.
We show that complete.
Okay, copy that. You can be expecting a call from Marshall shortly.
Okay, thank you much.
Mr. Johnson?
Atlantis, Houston, we need the star trackers back to track.
Okay, we copy.
Atlas 1 Huntsville with a voice check.
Huntsville, Atlas 1, we copy you, Sonny. You're a little bit low, but clear.
We have you loud and clear, Kathy, and the POC is go for payload activation.
Okay, we copy. Go for payload activation. We'll put it in work.
This is Space Lab Mission Operations Control in Huntsville. That exchange was between crew interface.
Huntsville, Atlas 1, we show step 1 already complete, and we're proceeding.
Copy that, Kathy.
The first exchange is there between the crew interface coordinator here in Huntsville, Sonny Mitchell, and payload specialist Kathy Sullivan, indicating that the air-to-ground communications link between Space Lab and payload control here in Huntsville has been established and is ready to support payload operations. So from now on, we'll be hearing discussions between the crew and the Huntsville control team, in addition to discussions with Mission Control in Houston. And we should be hearing further exchanges concerning activation of the Atlas 1 experiment systems. Once activation of the experiment systems is completed, the team will begin a busy agenda of science activities that have been laid out on the Atlas 1 timeline. And we were hearing that mention there of payload activation, a process which crew is now turning their attention to aboard Atlantis. It's about a 30-minute long procedure consisting mainly of...
Atlas 1, we just counted the SOPA 00 timeline a minute or so ago and got a horizon sun moon.
Copy that, Kathy, and that's expected.
This is Space Lab Operations. Mission Specialist Kathy Sullivan reporting an error message popping up on the data display system, but it was an expected one, which is part of the process of using the experiment computer to execute some of the payload activation procedures. Those procedures could be done either by the crew manually entering a series of commands, or by letting the experiment computer doing it through a pre-mission planned set of sequenced steps. And since things are running nominally with the...
Huntsville Atlas 1, payload activation is complete with the exception of step 7, and we're putting that in work right now.
Copy that, Kathy. Sounds wonderful.
It's really good to hear you guys' voices without my feet on the floor.
Yeah, we really enjoy it, too.
You enjoy today.
Mission Specialist Kathy Sullivan indicating that payload activation has gone very smoothly and is nearly completed ahead of schedule. The only activity still in work in that process, step 7, is setting up a laptop computer, which a laptop computer is used for some of the experiment operations during the Atlas 1 mission. And the procedure is one of unstowing the small computer and attaching a cable so that it will be configured for use with...
Atlas Huntsville for Kathy.
Go ahead, Sonny.
Kathy, can you confirm that on the DPM page all the depth statuses are op?
Stand by. And Huntsville Atlas 1, Sonny, good catch. We do not show all the depths opt. They are all opt at this time.
Copy that.
Atlantis, Houston, be advised your voice is now being recorded.
Houston, Atlantis, say again.
We are now recording voice on the HDRR.
Okay, thank you, Jeff.
And Atlas Huntsville, be advised of
And
your
Huntsville
ground
Atlas
commanding.
1, just to verify, do you want us to proceed and op all those depths, Sonny?
Stand by, Kathy. Okay, Kathy, your go to op all those depths.
That should work.
Atlantis, Houston, with a word on teleprinter.
Go ahead, Houston.
Yeah, Kathy, we've sent up the SARX teleprinter message as well as some test messages. Two of them, the SARX and one of the test messages has used the upgrade. We'd like to know what they look like.
Okay, Jeff. Right, you're going to send us up the test and the SARX test messages.
They should be on board now.
Alrighty, we'll go look for them.
And Huntsville Atlas 1, you probably see it, Sonny, but we show all the depths opt now.
We see that, Kathy. Thank you.
This is Space Lab Operations Huntsville. Kathy Sullivan, they're reporting that the depths are looking good. Those are the dedicated experiment processors, or the small computers specifically for various experiments that are part of the Atlas 1 payload.
Atlas Huntsville for Kathy.
Go ahead, Sonny.
Kathy, I'm not sure you copied me a minute ago, but we are doing some ground commanding now.
Okay, we appreciate the heads up. Houston, Atlantis.
Go ahead.
Yeah, just a comment for the Earth Ops guys. It's the first pass I've had a chance to take a look out the Atlas Mountains. There's a substantial amount of dust storm activity in the central Atlas Mountains just south of the main crest.
Okay, Kathy, and folks on the ground here just wanted an update on where you stood on the KU band antenna deploy and activation. Marshall would like to get that going as soon as we could.
Okay, we're getting to that right away.
Thanks a lot.
Atlas Huntsville for Kathy.
Go ahead, Huntsville.
Kathy, can you confirm Step 7 of Payload Act complete?
We're not complete with that just yet, Sonny. We've got a lot of activity on the flight deck right now.
Copy that.
Houston, Atlantis, K-band is deployed. We're commencing activation.
Copy that.
Huntsville, Atlas 1.
Go ahead, Kathy.
You're going to be go for the start battery charge on time.
Stand by. Atlas Huntsville for Kathy.
Go ahead.
Kathy, we'd like to have the KU band antenna activated before we do the CPAC start battery charge.
Okay, we'll hold for your call. It's in work.
Atlas Huntsville for Kathy.
Go ahead, Sonny.
Kathy, after further discussion with CPAC here, we'd like to go ahead and do the CPAC battery charge. If we could have either yourself or Dirk monitor the O2S page while you start the battery charge, that would be great.
Okay, we'll put that in work.
Thank you.
Space Lab Operations Huntsville. Crew Interface Coordinator Sonny Mitchell asking Mission Specialist Kathy Sullivan if the crew could proceed with one of the experiment activation steps, specifically on the particle accelerator experiment, or CPAC, which stands for Space Experiments with Particle Accelerators. The first activity involving that experiment system is to...
Go ahead.
Yeah, Jeff, we show the KU self-test should have timed out. We have 3 gray talkbacks as expected, but range and elevation are plus 333.3, so per the checklist, we're just giving you a call.
Okay, Kathy, we copy that, and we'll take a look at it. In the meantime, if somebody has the chance, we'd like on panel A6U to check that the payload retention latch 4, is off.
It is now, Jeff, thanks.
And this is Space Lab Operations. Again, the first activity involving the particle accelerator experiment, which we should be hearing initiation of momentarily, will be simply turning on a battery charging system. That experiment does use batteries, which have to be maintained above a specified level of charge prior to any firings of the electron beam accelerator or particle accelerator. And so once that charging process begins, it would be continuing.
Atlantis Recon.
Go ahead, Charlie.
Smoke detection circuit test is starting.
Okay, we copy that.
The battery charging again would be continuing for a number of hours.
Go ahead, Kathy.
Okay, battery charge has started at an MET. Started at an MET of 0 days, 3 hours, 46 minutes, 02 seconds. We show all battery cell voltages 2.8 plus or minus 0.04 volts. Charger temp was 31. The battery temps were 21, 22, 22, and 19.
Copy that, Kathy. Thank you. Atlas Huntsville for Kathy. Can you verify that we have 2 good charger currents?
Sure do, Sonny. Looks just like the PCTC, 0.1 each.
Copy that. Copy that. Thank you.
And this is Space Lab Operations. Sullivan there reporting that battery charging
Atlantis,
appears
Houston,
to be
we'd
nominal.
like you to go ahead and press on with the KU band activation.
Okay, Jeff, I understand we're going to complete the activation.
That's affirmative, Kathy. We think we understand what happened to the antenna, and we'd like you to press on.
Okay, and am I going to just do another item 7 to clear the self-test bug?
That's affirmative, Kathy. Another item 7.
Thank you much.
This is Space Lab Operations Huntsville. Mission Specialist Kathy Sullivan there a minute or two ago mentioned that the battery charging appeared to be proceeding just like it did in the PCTC. She was referring to the payload crew training complex here in Huntsville at Marshall Space Flight Center, where the crew has spent many, many hours training and in simulations working through the same procedures that they're currently executing in the flight. And Sullivan just mentioned that everything looked just the way it had looked in the PCTC.
Atlantis, Houston, with a switch throw on panel A1U.
Go ahead, Jeff.
Yeah, we need you to take control to command.
Okay, on A1U to command.
Good copy.
Okay, Jeff, that's complete.
Okay, copy that.
Houston,
Houston, Atlantis.
Go ahead.
Yeah, Jeff, in tags activation here, that switch you had us take up to command would be bringing back to panel. Do you want us to do that?
Stand by.
Lichtenberg.
Okay, Brian, it's fine. You can take the switch back.
Okay, thanks. And we're in the tags activation now.
Okay, copy that. Atlantis, Houston for Brian.
Go ahead, Jeff.
Yeah, Brian, we're 2 minutes from an LOS. We'll pick you up on the other side at 4:01. We'd like you to go ahead and perform APU cool-off on time. However, we'd like the steam vent heater deact to hold on that for a while. We'd like to watch them a bit longer.
Okay, I understand. We'll do the cool-off on time and hold on the deact.
Good copy, and we'll see you at 4:01.
Roger.
This is Mission Control. Houston, we've lost signal with Atlantis for just a few minutes as the vehicle has passed out of range of the communications tracking system. We'll reacquire the signal with Atlantis and crew in about a minute and a half. During the last orbit, Atlantis crew did an orbital maneuvering system burn using one of the 6,000-pound thrust engines, raising the orbit to almost a circular 160 nautical miles. That put the vehicle in the proper position to support the Atlas payload, the atmospheric laboratory for applications in science. And the Space Lab activation was completed by Mission Specialist number 1, Kathy Sullivan, and all of the activities associated with the payload activation were turned over to Huntsville during the last orbit. Atlantis is on the third orbit of 127 planned for this mission. The blue team is the primary team aboard the vehicle at this time. The blue team is made up of Charlie Bolden, commander, Brian Duffy, pilot, Kathy Sullivan, and Dirk Frimout, who is the payload specialist number 1. The red team, which is presently in their, or beginning their sleep cycle, it consists of mission specialist number 2, Dave Leestma, mission specialist number 3, Mike Foale, and payload specialist number 2, Byron Lichtenberg. That team will be in their sleep cycle for the next 5.5 hours or so, at which time they will be awakened and the two teams will switch and hand over to one another, allowing for 24-hour operations in support of the Atlas payload for this mission. The orbiter Atlantis is in good configuration to support all of the payload activities. There are no issues with the vehicle at all. The KU band antenna has been deployed, allowing for television transmission and data transmission to the ground through the tracking and data relay satellite network.
Atlantis, Houston, back with you.
Crews also conducted a wastewater dump, which is a normal routine operation that occurs every couple of days aboard the vehicle. There are also supply water dumps that occur throughout the mission. The smoke detection system aboard the orbiter has been checked, and that is working properly. And the crew has powered down some of the equipment that's not necessarily needed for this, for the on-orbit part of the mission. That allows for conservation of electrical power to support the full duration of the flight, which is scheduled to be an 8-day mission. So while Atlantis is in a good configuration to support the science activities for the Atlas payload, which has been activated, the orbiter is presently in a 160 by 159 nautical mile orbit, circling the Earth every 1 hour and 30 minutes. Again, Atlantis is on the third orbit of a planned 127 for this mission. We're at 4 hours and 2 minutes into the flight. Atlantis was launched at 7:13 and 40 seconds this morning, Central Time. This is Mission Control, Houston.
Atlantis, Houston for Charlie.
Houston, Atlantis, what do you need, Jeff?
Yeah, Kathy, we just wanted to make sure that the maneuver called out in the flight plan at 4:10 gets loaded.
Okay, stand by. Okay, Jeff, that maneuver is in work now. We're just catching up with some changeover items from post-insertion to the rest of the flight plan.
Okay, copy that.
And we appreciate the heads up.
Huntsville, PS1.
Go ahead, Dirk.
I'm ready for the API depth checkout on your goal.
Okay, we copy that. Stand by. Atlas Huntsville for Dirk.
Go ahead, Rick.
Dirk, you are go for the depth checkout when you're ready, and if you could let us know the status of. And Dirk, if you could let us know the status of the grid setup in step 7 of payload activation.
Huntsville, PS1 for Rick.
Go ahead, Dirk. Go ahead, Dirk.
You part of your sentence. I just got that we are going for API depth checkup. Catch benefits.
That's affirmative go for the depth checkout, and we were wondering about the status of the grid setup in step 7 of the payload activation.
That's in work.
Okay, copy that. Thank you.
This is Space Lab Operations Huntsville. Alternate payload specialist Rick Chappell there with his first air-to-ground conversation with payload specialist Dirk Frimout, giving Frimout the go-ahead to proceed with a checkout procedure for the dedicated experiment processor, or DEP, that's specifically for the one of the Atlas I experiments, the atmospheric emissions photometric imaging experiment, to be specific. And so Frimout will be proceeding with that, a test procedure essentially to determine the functional integrity of the DEP, or dedicated experiment processor. There are small computers known as DEPs for several of the various experiments aboard the Atlas I payload. And in the case of the dedicated experiment processor that's currently the subject, this computer is used to compute pointing commands and to cycle and control the detector assembly for each of the various different experimental runs that the photometric imager will be used for. This is Space Lab Mission Operations Huntsville at 4 hours 16 minutes mission elapsed time. Payload activation procedures continuing to move along smoothly, some of which we're hearing about on air-to-ground, and others which are underway by remote commanding, and which we won't be hearing about on the air-to-ground communications. For instance, just a couple minutes ago, the principal investigator for the atmospheric trace molecule spectroscopy experiment, or ATMOS, reported here to control team members in the Space Lab Mission Operations Control Facility that that experiment is up and running, has been turned on by remote commanding, and looks healthy. The atmospheric trace molecule spectroscopy experiment is one which is intended to gather data to map trace molecules, including ozone, in the middle layers of the atmosphere by measuring the infrared radiation which they absorb. It'll be doing that during orbital sunrises and sunsets, and recording the sunlight that passes through the Earth's atmosphere at the horizon, or as we'll be hearing, at the Earth limb. And by identifying the wavelengths of infrared light which is absorbed, this instrument will be able to identify the types of molecules that are present and record data on their locations. And we're now receiving the first live video coming down from Atlantis, showing a display screen, a data screen for the atmospheric emissions photometric imaging experiment. This screen is one which the payload specialist aboard Atlantis will be using extensively during the mission when the photometric imaging system is being used. And we're now taking a look in the science operations area here of Space Lab Mission Operations Control Facility in Huntsville, where some of the team members for that experiment, the photometric imaging experiment, are watching closely and anticipating seeing some of the data which will be showing on that display.
Houston, Atlantis.
Go ahead.
Yeah, Jeff, got the tags activated if you want to let Inco know.
Okay, we'll do that.
This is Space Lab Operations
Houston,
Huntsville.
we'll be sending you some tags test messages in about an hour. We have to let it warm up a bit.
Okay, Jeff, we'll be looking for him.
And we're currently seeing...
Go ahead, Dirk.
Rick, the depth checkout is completed and the readings of the are nominal.
We copy
Readings
that.
on the display are nominal.
We copy that, Dirk. Thanks.
This is Space Lab Operations Huntsville, members of the principal investigators team here for the atmospheric emissions photometric imager experiment. We're just getting some good news, some of the first good news in terms of the status of their experiment. Payload specialist Dirk Frimout reporting that the initial checkout procedure for that experiment, which is simply checking the operational integrity of the dedicated experiment processor, the specific computer in that experiment, checked out satisfactorily. Everything looks good, Frimout reported. And we're currently looking at Dr. Stephen Mendy, who is principal investigator for the photometric imaging experiment, and other members of his supporting team here in the science operations area of Huntsville.
Houston, Atlantis for payloads.
Go ahead.
Yeah, I just wanted to advise you that the STL activation and photographic requirements were complete at 3 hours and 51 minutes.
Okay, we copy that.
Again, taking a look here in the science operations area in the Space Lab Mission Operations Control Facility. This area supports experiment teams for the 14 experiments that comprise the Atlas I payload. And in all, there are operating areas here for approximately 85 members of the different science teams, consisting of scientists and support engineers for the experiments and technicians to support all the science activities going on during the mission and work any real-time problems which may come up. And of course, in the case of a number of the experiments, actually operate experiment systems remotely here from the ground. The capability, of course, is also available, if necessary, for members of these science teams to be enabled on air-to-ground and talk directly to the crew aboard Atlantis, should there be any need to provide some feedback from the crew members aboard Atlantis directly to principal investigators for the experiments.
Atlas 1.
Go ahead, Kathy.
Oh.
Standby 1. Okay, Sonny, we've got the grid powered up, connected to both ISO and API per the payload systems handbook, and we're ready to commence mount checkout on your go.
Copy that, Kathy, and we have one minor change from the pen and inks we made at crew review for the mount check procedure when you're ready to copy.
Stand by. Okay, Sonny, go ahead.
Okay, Kathy, on page NOM-6 of the API FOT2 mount checkout, that pen and ink that we made at crew review should be changed to 10 seconds instead of 30 seconds.
Okay, we understand. 10 seconds expected for rigid eyes.
That's correct. And with that, Kathy, you are go for the API mount checkout.
Okay, we copy go for mount checkout. We've got a little bit of remaining CTR configuring to do, and we'll be underway. We'll keep you closely posted.
This is Space Lab Operations Huntsville. Again, we're receiving some downlink video from aboard the Atlas 1 payload. This is, again, a display that's dedicated for the atmospheric emissions photometric imaging experiment. And it's a display which will be used, monitored here on the ground, as well as by payload specialist Dirk Frimout during a procedure which we should be hearing about shortly, a procedure called mount checkout of the photometric imaging experiment. It's a procedure to prepare the pointing mount on that low light level TV camera system, which is essentially what the photometric imager is. Prepare the pointing mount for operations in 0G. This operation also will include unlocking the launch locks in which the photometric imaging instrument is secured during launch and in which it'll be secured for landing. And there's also a step for engaging a load isolator, which connects the detector assembly of the photometric imager to its gimbal mount. And after this procedure is completed and verified, the photometric imager will be able to go into normal operations in which it will be a key element of the space plasma physics activities during the mission. Members of the science team here for the photometric imaging experiment will be monitoring these activities closely. It's a key step in making sure that their instrument can be pointed and aimed at the area which it will be used for imaging.
Go ahead, Kathy.
Yeah, Sonny, just wanted to verify whether you need any additional recording for the mount checkout other than the video routing that's called out in the PCAP.
Stand by.
This is Space Lab Operations Huntsville. This screen, again, video display, is one on which later in the mission we should be seeing actual images captured by the photometric imaging experiment. But during this procedure,
Atlas Huntsville for Kathy.
it's just being monitored for its data readouts.
Kathy, no additional requirements other than what's called out in the PCAP there.
Okay, we have the camera Charlie scene up on monitor 1, and we'll be recording that on board. We show ourselves complete through step 3 and proceeding with step 4.
Copy that. Sounds great.
Dr. Stephen Mendy here in the right-hand side of this view from the science operations area is principal investigator of the atmospheric emissions photometric imaging experiment. This TV image, again, once we go into the actual experiment operations, will be one in which the crew and ground control team members will be able to see images of some of the phenomena that that are the primary subject of interest in the Atlas I mission. For instance, faint optical emissions from various types of natural as well as artificially induced phenomena in the upper atmosphere. Among those phenomena, of course, are auroras, both natural auroras and artificially stimulated auroras, which are one of the objectives of some of the experiment activities planned during this mission. This procedure, again, which is currently underway aboard Atlantis on the aft flight deck, is one to check out and verify that the mount system, the pointing system for the atmospheric emissions photometric imager experiment is working nominally. Payload specialist Dirk Frimout is working through this procedure.
Go ahead, Kathy.
Okay, Sonny, at step 8, we show all lock temperatures within limits. I can read them down to you if you'd like. And we have all zeros for the gimbal temps. And in step 9, we verify lock number equals 7 and stow equals 0.
Copy that, Kathy. Sounds great, and we don't need the lock temperatures read down.
Okay, we'll proceed.
Payload specialist Dirk Frimout, again, is at the controls for this mount checkout procedure. He will be putting the photometric imaging system, experiment system, through its paces at a dedicated control panel on the aft flight deck of Atlantis. This experiment is one which is operated from a unique control panel. In fact, there are more than one control panel for the photometric imaging experiment. It's one which is operated primarily from its own control panel system rather than from the Space Lab data display units.
And Huntsville Atlas 1 for step 11, we have a lock number equals 0. Both the lock and unlock lights are off after 4 seconds of drive, and we're going to proceed.
Copy that, Kathy. Sounds wonderful.
And mission specialist Kathy Sullivan reporting some of the status indications as this mount checkout procedure is underway. All those indications sound good to the principal investigator team here on the ground. So Sullivan said they're continuing, working their way through this procedure, which is, as laid out in the timeline, would nominally take about 25 to 30 minutes.
Huntsville Atlas 1, we're beginning the bail operations at step 12.
Copy.
And a reminder regarding programming, coming up in about 5 minutes from now will be the first Today in Space program during this Atlas I mission. That'll be coming up at 12 noon Central Standard Time. Dr. Tim Miller will be the host or anchor of the program, and there will be a Today in Space program each day during this Atlas I mission, originating here from the Space Lab Mission Operations Control Center in Huntsville. This is Space Lab Mission Operations Huntsville. This display, again, coming down from Atlantis, and showing the status, some of the parameters and the status for operations of the atmospheric emissions photometric imaging experiment. It's a TV image which will be able to provide some actual images captured with the specialized low light level TV cameras that are at the heart of this photometric imaging system. But again, during this checkout procedure, which is underway, we're simply, the crew is simply putting it through some of its paces to make sure that the mount system is functioning nominally and that the instrument can be stowed safely for landing, prior to landing. And again, a reminder with the Today in Space program coming up on NASA Select in approximately 2 minutes. Live coverage of the Atlas I mission will continue on mission audio, while the Today in Space program is originating live here from Marshall Space Flight Center in Huntsville.
Huntsville, Atlas 1.
Go ahead, Kathy.
Okay, Sonny, we've just done steps 15, and I visually observed the detector pull back towards the mount as expected. However, we do not have the rigid stow light on as expected in step 16. If you guys concur, we're going to proceed with the starred block at the bottom of Nom 5.
Stand by.
This is Space Lab Operations Huntsville, and we'll be standing by momentarily for the Today in Space program at 12 noon Central Time, originating here from Marshall Space Flight Center in Huntsville. This is Space Lab Mission Operations Control at 4 hours, 44 minutes mission elapsed time.
Your go to the starred block on page 9-5.
Okay, that's in work, Sonny.
Houston, Atlantis.
Go ahead, Charlie.
Okay, Jeff, we're finally getting to it, but we're working the Group B power down, and we're ready to take IMU-2 to standby unless GNC or anybody else has anything they want us to hold for.
Okay, Charlie, we're go for that, and when you get a spare moment, we'd like to hear your post-ascent debris report.
Okay, and I'll give the mic to Brian. He was just putting it on the recorder. I'll let him give it to you.
Okay, copy that.
Houston, Atlantis, standby 1 on that, and Huntsville, Atlantis, the star block on Nom 5 worked fine, and we did get a rigid stow light. We're ready to proceed with step 17.
Copy that, Kathy, and it sounds great.
The ascent. Houston, Atlantis.
Go ahead.
Yeah, Jeff, I can give you a couple words about the ascent if you'd like them.
Okay, I think we're ready to copy.
Okay, Charlie and I both agreed that this runaway train seemed to have 3 different episodes of where we saw debris coming across the or around the nose and coming back and hitting the windows. The material was white in nature. It kind of looked like ice or small snowball type stuff. Hit the windows, W3 and W4 probably took it the worst, and they're fairly glazed over right now. Those 3 episodes happened at different Mach numbers. We'll have to, it's all on the ICOM recorder. We talked about it as we're going uphill, and we'll have to, when we get some time, maybe we can play that back and get the details, or we can just give it to you post-flight.
Okay, that sounds good, Brian.
Okay, and there's one other thing that wasn't a part of the debris, but we'd like to tell you a little bit about what Dave described from the tank when they were doing the ET photo DTO.
Okay, we're ready to copy.
Okay, as they had it in sight and they were watching it, Dave described what he saw was it was probably O2 or H2. It was spewing out periodically out of the inner tank area and gave Dave the impression that the thing was going to explode at any moment. We never did see that, of course, but he said he'd never seen anything like that before.
Okay, we copy that.
Huntsville Atlas 1.
Go ahead, Kathy.
Okay, Sonny, with our success at step 16, we now show ourselves complete through step 20, and we are ready to rigidize the detector.
Copy that.
Huntsville Atlas 1.
Go ahead, Kathy.
Yeah, Sonny, I guess I'd just like you to verify that you're all with us at step 21 and we're go to proceed.
We're with you, Kathy, and you are go to proceed.
Okay, thank you much. Huntsville Atlas 1.
Go ahead, Kathy.
Step 21 is all complete and all nominal. We have an R on line 4, and we verified a 4 amp increase on distribution box 1 amps on spec 220. Log number is 7, and we show ourselves in good shape.
Copy that.
00 on board.
And Kathy, that was caused by the ground.
Okay, Sonny, thanks. And Huntsville Atlas 1, we show mount checkout first part at least complete at 4:57, no anomalies.
Copy that, Kathy. Sounds great. Happy is really happy.
This is Space Lab Mission Operations Huntsville. Mission Specialist Kathy Sullivan reporting that one of the key activation steps, procedures for the atmospheric emissions photometric imaging experiment has now been completed, and everything looks good. That procedure is checking out the mounting system, the pointing system, which is a key element for that experiment, and a fairly lengthy procedure to step through in checking it out and making sure that everything's...
One with a question.
Go ahead, Kathy.
Yeah, Sonny, if you guys have a feel for it yet, are we going to perform this blue shift approximately on time, or would you like us to await each event for your call?
Kathy, we should be approximately on time here, so for the PCAP.
Okay, if you have no objections, then we're going to proceed with the grill cow.
Sounds wonderful.
And for the grill team members, the young Dr. Dirk Frimout will be performing this cow.
Copy that. And Atlas Huntsville, be advised that we have payload bay views.
Okay, Sonny, you were a little garbled there. I understand you're taking the payload bay cameras to take some looks.
That's correct, Kathy.
Well, it's a great-looking payload flying above a great-looking planet, so I think you'll enjoy it.
We're enjoying it.
And Huntsville Atlas 1, I'm going to take the Delta camera and show you some things that are flying formation with us.
And Kathy, we have lost the downlink video right now.
Okay, Sonny, I copy that. Do you expect to reacquire it, or can I power down the cameras?
Stand by. And Atlas Huntsville for Kathy, INCO is going to take care of powering down the cameras.
Okay, thanks a lot. Houston, Atlantis.
Go ahead, Kathy.
Yeah, Group B power down's complete, Jeff.
Okay, copy that, and we see it on the ground.
Okay, and for payloads and the POC, the grill mirror is go, and Dirk's proceeding with the check.
Copy that.
Huntsville PS1 for grill.
Go ahead, Dirk.
We put the shift, we do the calibration, everything seems nominal. The shift of 45, and it is given with delta gamma of -70. And we have done the second calibration. I'm waiting from you for continuing this calibration, for finishing this calibration.
Okay, we copy that. Atlas Huntsville for Dirk.
Go ahead, Dick.
Dirk, the grill folks would like for you to press on.
Okay, I see that we have a scaling one, a signal that is weaker than I expected. I hope that they concur with that.
Dirk, could you repeat that? You were broken a little bit.
The amplitude of the signal that I got for this calibration is lower than I expected. I just want to remark that. It can be that's nominal. It's just I have never seen it on the flight hardware.
Okay, we copy that.
So, but I press on. I will now shut down the grill spectrometer.
Atlas Huntsville for Dirk. Press on with the grill shutdown.
Copy. Huntsville PS1 for grill.
Go ahead, Dirk.
I see that the mirror is not locking in this shutdown mode. I got a star, so it is somewhere not completely locked. It is in the position azimuth 97.9, co-elevation is 71.6.
We copy that.
I got the error message as well. Just tell me what I have to do.
Stand by, Dirk.
The Huntsville PS1 for grill, the mirror is closed but not locked. Houston, Atlanta.
Go ahead, Kathy.
PCS1 config is complete, Jeff.
Okay, copy that.
Atlas Huntsville for Dirk.
Go ahead, Rick.
Dirk, the grill folks would like for you to do an item 18 at this point, and then they want to look at the data.
The ECAS has been removed. We were in phase 99, so the instrument was stopped, and now I cannot do it in item 18 because the ECAS is removed. So the mirror shows closed, but it's not locked. So we had 97 azimuth of 97 when just before the ECAS was removed, but the lock is not in, but it is closed.
Okay, Dirk, we copy that, and the grill folks would like for you to just leave it as it is for the time being. It should solve itself on the next operation.
I concur with that. That's correct.
Atlantis, Houston, with some words on your PCS1 config when you're ready to copy.
Go ahead, Jeff.
Yes, two things for you. One is we need a report of the cabin pressure, and also on L2, we'd like you to check that the O2 N2 controller valve system 1 is in auto.
Okay, Jeff, good catch on L1. It's in auto now. And we show 14.7 on the cabin P.
Okay, we copy. Thank you.
This is Space Lab Mission Operations, Huntsville. While the Today in Space program was underway, activities were continuing in activation of experiments and preparations for science activities during the Atlas I mission, with two of the instruments working in calibration procedures. We were just hearing a minute ago payload specialist Dirk Frimout involved in calibration activities on the grill experiment, which is a spectrometer that's been flown once before on Space Lab 1 mission. And it's an instrument which is designed to study on the global scale atmospheric parameters between altitudes of 15 and 150 kilometers. It does so by making high-resolution spectroscopic observations of the Earth's limb in those wavelength ranges which are characteristic of the vibrational or rotational lines of various atmospheric constituents. And we're now getting a look on downlink video from Atlantis of the payload bay, the instruments out in the payload bay of Atlantis, with the orbiter just about to pass across the terminator into the shadow portion of orbit 4. Zooming in here to take a closer look at the forward portion of the Atlas I complement of instruments and systems. Here in the foreground, we can see a large black spherical object, which is one element of the space experiments with particle accelerators experiment. That experiment has 3 of these large spheres for the purposes of charge collection or neutralization of any charges which may build up on the spacecraft during experiment operations. Again, over the past 30 minutes or so, while the Today in Space program was underway, activities were continuing, and one of the key steps in activation of the atmospheric emissions photometric imaging experiment was completed successfully. Mission Specialist Kathy Sullivan reported that the mount checkout procedure for that photometric imaging experiment went nominally, and everything looks good. The crew then next turned their attention to calibration activities on the grill spectrometer, and completed that procedure. A number of these instruments do have fairly precise calibration checks to make sure that any data they're collecting and sending down can be referenced precisely and plotted according to the relevant parameters. Another calibration procedure is currently underway. It's one which does not involve active crew participation. That calibration is a somewhat longer procedure on the atmospheric Lyman alpha emissions instrument, or ALAE, which is one of those experiments which operates primarily from the pre-planned computerized timeline and from remote commanding from the ground.
Atlas Huntsville for Dirk. Yes, Dirk, the grill folks did not get good data through the HRM that on that last cal, and they would like, if you have time, for you to run the cal sequence one more time.
Okay, I copy. I can do that now straight away.
That's affirmative.
alternate payload specialist Rick Chappell there requesting Dirk Frimout to repeat the calibration procedure on the grill instrument, the grill spectrometer, since members of the team for that experiment here on the ground reported they were not seeing data in real time through the high rate multiplexer system, and they do need to see that data in order to verify that everything looks good in terms of calibration. So they asked that Frimout repeat the procedure. We should be hearing that coming up shortly. Meanwhile, we continue to receive video from a payload bay camera looking at various elements of the Atlas I complement of instruments. We're now looking at the antenna, part of the system for the millimeter wave atmospheric sounder instrument. This instrument is a remote sensing device for what's known as passive sounding of the Earth's atmosphere. And it picks up radiation emitted by the atmosphere, emitted by different constituents of the Earth's atmosphere in a range, across a range of different wavelengths. It acts somewhat like a passive radar device, like a radar in the sense that it picks up sensitive signals coming from a source, but it is not actually an active device. In other words, it doesn't send out signals itself. It picks up emissions from the constituents of the atmosphere, and that those emissions will yield information about the distribution.
Huntsville PS1 for grill.
Go ahead, Dirk.
The grill experiment is on, and the mirror is opening now to the standby position. So we are on phase 10. Can you confirm that the grill people have correct data?
Stand by. Atlas for Dirk, the grill people have got good data at this point.
And Atlantis now has crossed into the shadow side of this orbit, so we're seeing in the background a view towards deep space and the star background. Panning now up out of the payload bay and taking a look at a portion of the night sky, with Atlantis currently nearing the southern extreme of this 57-degree orbit. It's currently above the southern tip of Africa.
Huntsville PS1 for grill.
Go ahead, Dirk.
I got the calibration spectrum that is not recognizable. Current delta gamma is -70, but I see gamma start is 9759.
Copy 9759, Cal spectrum not recognizable. Atlas Huntsville for Dirk.
Go ahead, Rick.
Dirk, the grill folks would like for you to try one more cal with an item 6 on display 13G.
Okay, I'm ready. I do item 6 on my mark. 3, 2, stand by. Item 6 on my mark. 3, 2, 1, enter.
Copy that.
Program mode into cal. Okay, the gamma start went to 6203, and now I get the calibration spectrum that is correct.
We copy.
STS-1 for grill. Can you confirm that they get the correct data on the ground?
Dirk, they say they have good data quality at this point. Thank you.
Give me a sign when I can shut down the grill.
Your go to shut down the grill.
This is Space Lab Mission Operations Control in Huntsville. Payload Specialist Dirk Frimout there getting go ahead to shut down the grill spectrometer instrument after verification that the principal investigator team here on the ground was indeed seeing good data through the high-rate multiplexer downlink. Frimout repeated the calibration procedure, a fairly brief procedure on that instrument, a couple of extra times since the first time he went through the procedure. The principal investigator team was not able to monitor the data in real time. The subsequent and that final calibration procedure, the team here on the ground reported they did see good data.
And I got the mirror lock sign for this run. So the mirror is locked. Mirror closed and locked in position 9, 0.7, and co-elevation 71.6.
We copy that, Dirk. Sounds good. And Dirk, the grill people are quite appreciative.
Atlantis, Houston, we're 2 minutes from an LOS.
I cannot see if the detector cooling is getting up. The detector cooling is staying on the 6.5 degrees Kelvin till ECAS is removed. So now I'm not sure if the detector cooling is off. But for the rest, everything seems nominal.
Atlantis, Houston, we're 2 minutes from an LOS. We're going to pick you up on the other side at 5:35. We've put 10 pages through the tags. We'd like you to check it for us and contact us on the other side.
Okay, Jeff, we'll do that. And looks like we got some pretty good aurora coming up here on this southern pass.
And Huntsville, for the Yappy folks just going over the hill here, we do have some pretty good aurora. Just off the aft of the vehicle on this path, I would characterize it as medium bright rayed aurora.
Copy that, Kathy.
This is Space Lab Mission Operations in Huntsville. We will be losing communications momentarily with Atlantis as it passes out of range of the tracking data relay satellite system. We were just hearing there, though, a observational comment from Mission Specialist Kathy Sullivan, passing along a sighting for one of the science teams here on the ground, something that probably is of interest for the photometric imaging experiment. Sullivan reported just a visual sighting of some interesting aurora as Atlantis is now near the southern extreme of its orbit and well within range of observing the aurora phenomena at the southern pole of the globe. That sort of auroral phenomena, of course, will be a primary subject of observations as we get into the real science activities of this mission. So with experiment activation activities well underway now, and some of the instrument calibration procedures having been performed by the crew, we're moving rapidly along towards actual science activities. At 5 hours and 32 minutes mission elapsed time, this is Space Lab Mission Operations Control in Huntsville.
Atlantis, Houston, back with you.
Houston, Atlantis, loud and clear. Huntsville, Atlas 1.
Go ahead, Kathy.
Yeah, so just an update for you guys on the auroral structures on this pass. About 5 hours, 33 minutes, 42 seconds, we came into a region of brighter aurora. We had two active arc regions. that came up towards us. We believe the tops of the rays were up to or close to our altitude, and the brightest of the arcs extended very close to our latitude. I showed us at the time at 56.7 south and 77 east.
Copy that. Sounds great.
This is Mission Control Houston. We have reacquired the signal with Atlantis and crew to begin the last leg of the 4th orbit of the mission. Our next television event is a mission status briefing with Mission Operations Director Lee Briscoe and the Manager of Payload Project Office, Harry Kraft. That briefing is scheduled to begin at 1 o'clock Central Time. That's in about 10 minutes.
In Atlas Huntsville, for Kathy, we're all real jealous about that aurora you're looking at over your lunch.
Well, it was an awful long way since breakfast, so lunch is really feeling good. Most of us were hungry on the pad, Rick, but it is a great sight out the window for eating lunch with.
Fantastic.
During the last orbit, pilot Brian Duffy radioed down his ascent debris report. That's a standard report that the pilot or commander gives after the ascent phase of the flight. He reported that he didn't see anything abnormal.
Rick, if you guys can just get NOAA to schedule up some solar activity, we'll really go gangbusters.
We'll give it a shot.
And Duffy reported that on 3 separate episodes he saw some small ice particles that looked sort of like small snowballs hit some of the windows during the ascent phase. Other than that, it was fairly normal ascent with very little debris reported. He also reported that Mission Specialist Dave Leestma, as he was doing an external tank photo DTO, that's a detailed test objective.
Go ahead, Jeff.
Yeah, FAO and INCO would like some words back on whether the tags page is forwarded through okay, and also what the quality of the teleprinter messages look like.
Okay, Brian and Charlie are down below just now. We'll have that for you in a second. And for the lab folks, we are going to NOP to the experiment and subsystem computer and power off the payload station DDS at this time.
And during that...
Houston, Atlantis, how copy?
Yeah, Kathy, they're talking about standby.
Okay.
Kathy, they're go to have you go ahead and do that.
Okay, thank you much.
And during that photo DTO, or detailed test objective of the external tank, Leestma reported to the blue team that he thought he saw some fluid or something coming out of the tank that he hadn't seen before, possibly O2 or H2. The tank was already separated from the orbiter at that time, and Leestma is mission specialist number 2. He's on the red team, which is in their sleep cycle. He is scheduled to wake up in about 4 hours from now. He did report that that appeared to be something he hadn't seen before. However, Brian Duffy, the pilot on the mission, is a first-time flyer, and the external tank DTO was performed by Dave Leestma. Again, coming up in about 5 minutes is our mission status briefing. That's a daily occurrence. That occurs at 1 o'clock Central Standard Time, and that's with Mission Ops Director Lee Briscoe and Payload Project Office Manager Harry Kraft. Again, that's upcoming in about 5 minutes.
Houston, Atlantis.
Go ahead.
Okay, for FAO on the tags traffic, we got 10 pages aboard. As expected, they were black in the first couple of sheets, but they were good white quality by the last of the run.
Okay, copy that.
And Brian's getting the teleprompter messages out right now, so we'll have words for you shortly.
Okay, sounds good.
Crew member Kathy Sullivan reporting on the success of activating the text and graphics system, or tags, aboard Atlantis. That's facsimile machine that's used to transmit information from the ground to the crew. Also, the crew has a backup, uses a teleprinter.
That's the Atlas 1. Also for the Aurora folks, we're still in a region of some faint, unstructured aurora. Some of the wisps do appear to come almost up to our height, Rick, and I show us at about 47 degrees south latitude.
Copy that.
Huntsville, Atlas 1.
Go ahead, Kathy.
Rick, for the CDMS procedures, we just wanted to let you know we've gotten 2 Horizon Sun Moon 09ers as we came into the terminator here. They're probably expected.
We copy.
Space Lab Mission Operations Control in Huntsville. And all is relatively quiet in terms of air-to-ground contact with Atlantis currently, as the crew is currently in their scheduled lunch period, about halfway through the hour which is nominally scheduled for the lunch break. However, some of the activities involved with activating experiment systems for science gathering activities are continuing, with of course some of the experiments not requiring any active crew involvement for activation, and for that matter when it comes to actual science data gathering. One of those activities, which has been underway for about 90 minutes and was scheduled to conclude just a few minutes ago, was a calibration activity on the atmospheric Lyman alpha emissions experiment, one of the atmospheric instruments aboard the Atlas 1 payload. And again, calibration activities are one of the primary efforts at this stage in the mission, since when these very precise instruments are first brought up and activated, the key element is to make sure that measurements that will be taken of the parameters of interest will be accurate. In this case, the instrument is intended to measure, and it'll be a first-time type of measurement, the levels of atomic hydrogen and deuterium, or heavy hydrogen, in the atmosphere. So that calibration procedure, which was again taking about 90 minutes, is one in which some specialized calibration lamps within the instrument are powered on and used as a source.
Atlantis, Houston, we're 2 minutes from an early TDRS handover to TDRS East.
Copy that, Jeff.
And again, for that calibration sequence, hydrogen deuterium calibration lamps are powered on, and absorption cells, which are key elements of the instrument itself, are run through a sequence according to a predefined data table, while principal investigators team here on the ground monitors the measurements from the instrument. Also, just a few minutes ago, another of the atmospheric instruments was turned on for the first time here during the mission, that instrument being the millimeter wave atmospheric sounder, which is one using a small dish antenna system to look at microwave radiations emanating from different constituents of the atmosphere. And this activity with the millimeter wave atmospheric sounder also is one which will not be at this point providing any actual scientific data, but rather This initial operation is part of the evaluation and checkout procedure in which members of the science team here on the ground will be putting the instrument through some of its paces and making sure that performance appears to be as predicted. Atlantis, meanwhile, is on its northward swing here on orbit 5, about to transit the North American continent. We're currently at 6 hours, 14 minutes into this Atlas 1 mission. This is Space Lab Mission Operations Control in Huntsville.
Houston, Atlantis.
Go ahead.
Okay, Jeff, we got one blank tags page and one good test page.
Okay, we copy that, and that's all we've sent so far.
Roger that.
And Kathy, the people on the ground here are still awaiting some words on the teleprinter when you have a chance.
Okay, Jeff, stand by just one.
Space Lab Operations Huntsville, we're getting a look here at the Atlas 1 payload, some of the instruments in the payload bay. Taking a look from the aft area of the payload bay. And in the foreground, we're seeing the grill spectrometer instrument at the left-hand side of this view, covered with some of the insulation material. Towards the forward end of the payload bay, we're seeing the large black spheres, which are charge collection devices associated with the space experiments with particle accelerators apparatus. And we're receiving this downlink video with Atlantis currently transiting over the mid-portion of Canada, about to cross the southern portion of Hudson's Bay. Zooming in now to take a look at the KU band antenna. And of course, this live video is received by means of the KU band antenna, transmitting the video signal through the tracking and data relay satellite system and down to the ground.
Houston, Atlantis.
Go ahead.
Yeah, the teleprinter messages were both fine, and we got all of them, thanks.
Okay, Brian, and we've sent you 2 more tags messages, and they should be on board now.
Okay, I think we just picked them out of the bin, thanks.
And Brian, one more thing for you. Just wanted to give you a heads up that we've commanded power amp 1 off. So if for any reason you need to do a panel command to get comm back with us, you'll have to wait the warm-up period on the power amp before you can talk to us.
Okay, power amp 1 has been commanded off. Is that just to save power?
That's affirmative.
Thanks.
Huntsville, Atlas 1.
Go ahead, Kathy.
Well, Sonny, for your box score, you can go ahead and show the 35 and 16 camera complete, setup complete. We've got every piece of photo gear imaginable around the aft flight deck.
Copy that, Kathy.
Houston, Atlantis.
Go ahead, Charlie.
Yeah, Jeff, we think we're finally caught up on the orbiter side of the house. Let me give you the last couple of things, and then you can look through the flight plan and tell me if you're missing any more info. The DTO 623 setup was complete at 5 hours 23 minutes, and DSO 611 microbial air sampler. We took samples on the mid-deck and the flight deck over the period from 5 hours 45 minutes to 6 hours 5 minutes.
Okay, Charlie, we copy that, and heads up to you that the trim burn at an MET of 9 hours will not be required today.
Okay, we copy. No trim burn at 9 hours. Thank you.
This is Mission Control Houston. We're 6 hours and 57 minutes into the flight of Atlantis on the Atlas I mission. All has been very quiet aboard the vehicle during the last hour or so as the crew has gone through their meal period of the blue team's wake shift. The crew of STS-45 is divided into two teams, a blue and a red team. The red team consists of Dave Leestma, Mike Foale, and Byron Lichtenberg. They're in the middle of their sleep period. Actually, their wake period begins, they'll be waking up in about 2.5 hours, at which time there'll be about an 1.5 to 2 hour handover period between the two teams. And then the blue team will begin their 8 hour or so sleep period. The blue team, which is now awake and conducting experiments in support of the Atlas mission, consists of Charlie Bolden, Brian Duffy, Kathy Sullivan, and Dirk Frimout. Commander Charlie Bolden was reporting just a few minutes ago that they have apparently caught up on all the activities on the orbiter side of the house. That included activation of some of the experiments, one called a DTO, or Detailed Test Objective. That's simply a cabin air monitoring device. And that particular DTO is made up of some solid sorbent sampler material that's basically used to sample the orbiter's atmosphere throughout the duration of the flight. The other DSO, or Detailed Supplementary Objective, that Bolden referred to was DSO 611. That's the Air Monitoring Instrument Evaluation and Atmosphere Characterization Experiment. And that's simply designed to evaluate and verify the air monitoring equipment to ensure that its proper function and operation during the mission. Data from this DSO will be collected on contaminant levels during the missions of varying durations, and it will be used to establish baseline levels in evaluating potential risk to crew health and safety. So those are two minor experiments that are that will be ongoing throughout the STS-45 mission. Upcoming during the next orbit, the crew will activate another experiment. That is the begin to unstow and set up the SSBUV experiment. That's an experiment that takes up two getaway special canisters in the forward right-hand part of the payload bay. SSBUV stands for Shuttle Solar Backscatter Ultraviolet Experiment, and it's designed to measure atmospheric ozone levels. It's used in calibrating experiments that are co-manifested on the Atlas I payload. Measurements taken by the SSBUV instruments are compared to those from ozone observing instruments aboard the National Oceanic and Atmospheric Administration, or NOAA, satellites 9 and 11, and also NASA's Nimbus 7 satellite. The data used from the SSBUV and those satellites ensures the most accurate readings that are possible for ozone trends. Crew will also activate the Visual Function Tester experiment, the objective of which is to measure changes in a number of vision parameters in the vision of crew members that are exposed to microgravity. This instrument or experiment consists of a handheld battery-powered test device which incorporates a binocular type eyepiece and uses controlled lighting to present a variety of visual targets for the crew. On this mission, the payload specialist will be the primary subjects for VFT, or Visual Function Tester, and will perform the testing at 2 weeks and 1 week intervals prior to the flight, as they have done, and in flight they will be tested each day. And once back on the ground after the mission, the 2 crew members will be tested 2 days after landing and then an additional 1 week after landing. The purpose of this VFT, or visual function tester, is to measure changes in the contrast ratio in the vision of the missions or the crew members that are exposed to prolonged zero gravity or microgravity. All of the test results are read on a display and also recorded on data sheets by the crew members.
Atlantis, Houston for Charlie.
Go ahead, Jeff.
Yeah, Charlie, we're 2 minutes from an LOS. We're going to pick you up on the other side at 7:08, and when all the folks are finished with their meal, we could save some power by powering down the galley.
Okay, we copy.
And Huntsville, Atlas 1.
Go ahead, Kathy.
Okay, Sonny, another good bit of aurora on this pass. One arc does come all the way out, positively comes up as far as our latitude, and there's some other diffuse active regions in the vicinity of our sub-satellite point. The arc that's just beneath us strikes off towards the southern oval, and there's a very bright, moderately to very bright set of active regions far south of our orbit, typically rayed, and again, up to our altitude.
Copy that, Kathy.
We've temporarily lost communications with Atlantis and crew through NASA's tracking and data relay satellite network. It's a very short loss of signal period with the crew that lasts for about a minute, as Discovery is at the lower peak of its inclination of 57 degrees. Crew aboard Atlantis just wrapping up their meal period and getting ready to step back into their timeline. The orbiter crew, consisting of Commander Charles Bolden and pilot Byron Duffy, will begin activating several of the middeck and secondary experiments, while the payload crew, Mission Specialist 1 Kathy Sullivan and Payload Specialist 1 Dirk Frimout, continue with the Atlas 1 experiments on the pallet in the aft portion of Atlantis' payload bay. At 7 hours and 7 minutes into the flight of Atlantis, this is Mission Control Houston.
Atlantis, Houston, back with you.
Okay, Jeff, we have you loud and clear. STS-1.
Go ahead, Dirk.
We got the message, diagnostic error 01. It was at 22:46. 20 hours, 22 minutes, 46 minutes. The diagnose error is the message, 01.
Okay, we copy
are
that.
by. If you have to do something, just give us a call.
Okay. Atlas Huntsville for Dirk.
Go ahead, Dick.
Dirk, I've got some information on a couple of the API runs that we are coming up on in terms of run numbers and a setup number for the handheld camera operations when you're ready to copy.
Stand by.
And Dirk, you might look at the API procedures on page NOM 35, and I can explain the approach here a little bit more clearly if you've got that in front of you.
Stand by, I take it. Okay, Rick, I'm with you on page NOM 35. I'm happy.
Okay, Dirk, this StarCal FO4A has a series of different filters that you go through in this run number 1, and they would like for you for each filter to begin with a high voltage setting of 1 and then ramp that up to find the appropriate high voltage setting. So that would be for each one of the 8 filters that's listed there, begin with a high voltage of 1 and then adjust it as appropriate.
I copy. For each filter, start with high voltage 1 and then ramp it up to see the image.
That's affirmative. And since you'll be setting up the next run of API at the end of your StarCal run, let me give you that information also. It is an FO4 airglow at 11:08 MET, and it would be run number 1.
Copy. Run for FO4, run number 1.
That's affirmative, and that will be at an MET of 11 hours and 8 minutes.
Yes, that's on our books already. We have copied that.
Okay, and we can also verify for Kathy that the handheld camera setup number 23 is a good number for the run at 8:25.
Kathy got the message. Coming back to the next API run, FO4A. So, will you stand by? Do you have real-time data? Could you follow it, or do we together, or do we do it on our own?
I believe we have real-time data. So we'll be with you on that. It follows immediately after you do the mount checkout.
Okay, so we will be in contact with them. We have in the meantime Horizon Center send moon messages 2 in a row.
We copy.
We got a message of Diac Cache 03. We had that already before. Before it was a 01, now it's a 03. No, sorry, it was a 03, excuse me.
Okay, we copy that, Dirk. And Atlas for Dirk.
That's it's an error, it's an SCOS message, not a NICOS message, so it's not for you. So we got another send moon message. Go ahead, Rick.
Yeah, we copy that, Dirk, and a correction to what I said a minute ago. We will not have we'll have real-time API data during the mount checkout, but then we'll be recording during the StarCal.
Okay, so I'm on my own to check the focus of each of the filters. So I try to do one after another as much as I can in one pass.
That's affirmative.
Houston, Atlantis.
Go ahead.
Yeah, Jeff, I presume that once again no action is required on our part with the SCOS diag cache message.
That's affirmative, Kathy, and we're going to get you some words on that momentarily.
Okay, I'd appreciate that.
Atlas Huntsville, the Horizon Sun Moon messages we're looking at, and we'll get back to you on that.
Okay, Rick, we appreciate the words.
Atlantis, Houston for Kathy with some words on your error messages.
Go ahead, Jeff.
Kathy, apparently the AP101 has a error correction circuit that goes through and scans for bit errors, and whenever it finds one, it corrects it, but then generates an error message. There's no impact to you. We can inhibit those error messages on ECOS, but we can't do it for SCOS. And for more words on the messages, you'll find in the Space Lab ref data, page 3-11 and 3-29.
Okay, we'll take a look at ref data when we get a chance, and we appreciate those words. And for the POC, you're probably following the string of messages. We'll just stand by for your instructions on any of the sun-moon discretes. We're up to about 8 of them now, Rick, and they're occurring about every 40 seconds.
We copy that.
Atlantis, Houston, with some switch throws on A12.
Go ahead, Jeff.
Yeah, we need the APU heater, gas generator fuel pump, 3 switches, B auto.
Okay, that's complete.
Huntsville Atlas 1.
Go ahead, Kathy.
Okay, Sonny, we're ready for the second part of Happy Mount checkout, waiting for your go.
And Kathy, the POC is go for the second part of the mount checkout.
Okay, that's in work. Huntsville Atlas 1.
Go ahead, Kathy.
Yeah, Sonny, we've got objective select of 0 set in there. We show that to be a stowed FO, so we don't expect in step 5 that we're going to see a core elevation of 0. Can you verify that?
Yeah, Kathy, stand by.
Houston, Atlantis.
Go ahead.
Yeah, RME was activated at 7 hours, 43 minutes.
Brian, we copied 7 hours, 23 minutes.
It was 4-3, Jeff.
Okay, copy that. Atlantis, Houston, we're 2 minutes from an early TDRS handover to TDRS East.
We copy.
And Atlas Huntsville for Kathy. Kathy would like you to go to the cursor pan mode.
Okay, we copy, Sonny. We go to cursor pan to this FO.
That's correct, Dirk.
Huntsville PS1. Happy is coming out of the locks. We can see it here on the pallet. Very nice.
We copy that, Dirk. Good news.
This is Space Lab Operations Huntsville, expecting science television shortly from the photometric imaging experiment. That experiment now in the process of mount checkout. This test prepares the pointing mount for operation of that experiment in a 0G environment. The operation also includes unlocking the launch locks and in gauging the instrument. The photometric imaging team here in Huntsville showing indications that the instrument was coming out of the locks. The crew on board Atlantis also reporting that activity. Space Lab Operations Huntsville now receiving real-time video downlink of the photometric imaging experiment, or API. Video downlink in the form of 4 lines of data indicating the status of the checkout procedure of the photometric imaging experiment.
PS1 for Happy.
Go ahead, Dirk.
We went through the shutdown and we got all the messages still stow equal 1. Verified then we got the message in proper stow, not locked.
Okay, Dirk, we copy that. Stand by.
0.
Okay, Dirk, we're looking at it on the ground. Stand by.
Huntsville Atlas 1.
Go ahead, Kathy.
Okay, Sonny, we're looking at MAL 3.1 on page MAL-4. We do have a rigid stow light. We do not have a lock light on, and the lock number is 0, as Dirk reported to you. So we're standing by, but per the published procedure, our next action will be block 5.
Okay, we copy that, Kathy, and I'll have some words up to you as soon as I can get them.
Okay. And Sonny, I guess one other piece of information for you. We show the co-LNAs as 90.7 and 089.8.
Copy that, Kathy.
This is Space Lab Operations Huntsville, the photometric imaging team monitoring their video screens, looking at data being received in real time from the photometric imaging experiment on board Atlantis. Scientists here in the science operations area. Mission specialist Kathy Sullivan working a set of procedures as a result of the data received from a checkout procedure that they are currently undergoing with photometric imaging experiment. The data indicating that the instrument is in a stow position.
Atlas Huntsville.
Go ahead, Huntsville.
Kathy, the happy folks would recommend that you press on with MAL 3.1.
Okay, we copy that, Rick. We're proceeding with block 5. Huntsville, Atlas 1.
Go ahead, Kathy.
Okay, Sonny, block 5 worked. We have a lock light now. We do also have a primary servo fault light, which we have not yet attempted to reset.
Copy that.
And if you have no objections, we will reset the primary servo fault.
Stand by, Kathy.
Atlas Huntsville for Kathy.
Huntsville, Atlas 1, go ahead, Sonny.
Kathy, Happy says there's probably no need to reset that because it'll probably fault out on you again immediately.
Okay. We're down in the lock, Sonny. We'd like to reset it to try to clean up the panel indications if you have no objection.
Stand by, Kathy.
Huntsville PS1 for Happy.
Go ahead, Dirk.
We resetted the fault light, the primary fault light, and now it's coming on again. Give me an indication if you can proceed and just shut it down, this experiment.
Stand by, Dirk. Earl.
Atlantis, Houston for Charlie or Brian with some changes to your attitude timeline on page 4-2 of the flight plan.
Okay, Jeff, we'll be right with you.
Okay, Jeff, we're ready.
Okay, on page 4-2, entry number 11, since we're replacing the trim burn, we'd like you to enter in there a start time of 8 hours, 49 minutes, 0 seconds, target ID of 2, body vector 3, pitch 90, yaw 0, Omicron 180. And then on entry 12, we'd like you to change the start time to 9 hours, 44 minutes, 0 seconds.
Okay, Jeff, we copy. In maneuver number 11, we want to change the start time to 8 hours, 29 minutes, 0 seconds. It's going to be target ID of 2, body vector 3, pitch of 90, yaw of 0, Omicron 180. Number 11, all you want to change is the start time to 9 hours, 44 minutes, over.
Charlie, on entry 11, it was 8 hours, 49 minutes, 0 seconds, and entry 12, 9:44.
Okay, and understand 8:49er.
That's correct.
Okay, we copy.
This is Space Lab Operations Huntsville. The Atmospheric Emissions Photometric Imaging Experiment team continue to monitor real-time data they are receiving from Atlantis. Their experiment, the photometric imager, continues through a mount checkout procedure. That experiment is designed to observe faint optical emissions from both natural and artificially induced phenomena in the upper atmosphere. It is one of several plasma physics experiments aboard the Atlas payload. Here at the Space Lab Operations Control Center in Huntsville, we continue to receive real-time downlink video from the photometric imaging experiment.
Huntsville, Atlas 1.
Go ahead, Kathy.
Yes, honey, just a reminder, we're standing by with instruments and control power on API, waiting for your go to clean up from the mount checkout.
I understand, Kathy, and right now the POC and the Mission Control Center are talking about this, and we'll get back with you as soon as we know something.
Okay, we figured that was so, and we'll just stand by for your call.
This is Space Lab Operations Huntsville, continuing to receive real-time video downlink from the Atmospheric Emissions Photometric Imaging Experiment, or the API experiment. The ground control science team here in Huntsville and the science operations area continuing to monitor the video.
Huntsville, Atlas 1.
Go ahead, Kathy.
Okay, Sonny, I guess we assume that we should just defer the star cal here at 8:22 and pending the discussions with Houston.
Kathy, we're still trying to get a resolution on it, so just hold on right now. Happy. Stand by, Kathy.
On the Atmospheric Emissions Photometric Imaging Team, Shift Leader Earl Amat and Engineer Skip Hassler continuing to monitor data being received from that
Atlas
experiment
Huntsville
in the
for
form
Kathy.
of 4 lines of data.
Go ahead, Sonny.
Kathy, we'd like to go ahead and proceed with the API 4A star cal at this time. After big discussion with the MCC and here at the POC, API believes that when you got that sun in the field of view message, that it caused their depth to temporarily lose its mind, and that's why we didn't get we got the improper stow. And the conclusion is that when we broke the mount check into 2 pieces, we should have had you go in and disable the sun sensor so that this wouldn't have happened. But now that it has, we'd like to go ahead and do the star cal, and which is at night, and we think everything will be fine after that.
Okay, Sonny, we copy that. We did not see a sun and field of view on board. I guess you saw that discrete in the down list?
We sure did, Kathy. We were sitting here staring at the monitor.
Okay, we copy that, and we'll put the star cal in work.
Sounds great.
And Huntsville, Atlas 1, Sonny, just verify for me that the recommendation from the API team is that we leave the primary servo fault set and just proceed on into the next FO.
And Kathy, API would like to reboot the DEP and then reset that servo fault light and then proceed with the star cal.
Okay. Okay, we copy, Sonny. we're going to reboot the depth per the procedure, and then we'll reset the servo fault and go ahead to star count.
Sounds good. And Atlas Huntsville, for your information, the VAS should be configured for the API video on DITR number 2.
Okay, we copy that. Thanks for the help.
Atlantis, Houston, we're about a minute and a half from a TDRS LOS. We'll pick you up on the other side at 8:43.
Okay, Jeff, we copy. See you at 8:23.
This is Space Lab Operations Huntsville. Several unattended operations have been ongoing on board Atlantis. It's part of the Atlas 1 mission. One of those experiments is the millimeter wave atmospheric sounder experiment. This is a remote sensing instrument which is involved in passive sounding or taking a look at the Earth's limb through the atmosphere from the shuttle. This instrument takes a look at ozone concentrations and trace molecules involved in the creation and destruction of ozone. The millimeter wave atmospheric sounder, or MAS, will provide for the first time information obtained simultaneously on the temperature and on ozone concentrations in the atmosphere. Another unattended operation as far as crew involvement is concerned is the astronomy experiment on board the Far Ultraviolet Space Telescope. This experiment looking at far ultraviolet sources of energy, clusters of galaxies. Shortly, the Faust team will be taking a look at the telescopium cluster of galaxies, receiving information from that observation time, real time. The Far Ultraviolet Space Telescope experiment has a very wide field of view, allowing the instrument to look at a large area of the sky, taking in a star survey. This experiment helping scientists to understand the evolutionary life cycle of stars. As an ultraviolet light source, an instrument looking at ultraviolet light sources, scientists can also better understand the evolutionary life cycle of the sun.
Atlantis, Houston, back with you.
Loud and clear, Houston.
Meanwhile, the crew continues to monitor another experiment, the photometric imaging experiment. They will be involved in a star calibration, focusing the instrument. This is one of the plasma physics experiments on board Atlantis. The orbiter Atlantis continues in the 6th orbit on the Atlas 1 mission at 8 hours 42 minutes. This is Space Lab Operations Huntsville.
Go ahead.
Yeah, Jeff, I guess looks like we're about ready to activate SSPUV if you are.
Okay, we're ready for that. Atlantis, Houston for Kathy.
Go ahead, Jeff.
Just wanted to let you know that we've uplinked an inhibit to the scrub error messages to ECOS, so you shouldn't be getting any more of those on ECOS.
Okay, we appreciate that. Huntsville Atlas 1 for the happy folks.
Go ahead, Kathy.
Dirk will have words for you in a minute about the star cow with the API instrument, but some words with the handheld camera. I have shot 30 shots according to setup 23. Have about 5 different triplets throughout the star field over the course of this night res as best I can, matching the stars that were evident in the continuum camera seen on API. In addition, however, I went ahead and shot a number of just handheld images showing the morphology of the aurora that we saw on this rev, and once again it was fairly dramatic, starting with diffuse rate forms at the perimeter of the oval, and as we neared the center of the oval, several distinct arcs with very strong, bright rays.
Copy that, Kathy. It sounds great. Go ahead.
This is Mission Control Houston at 8 hours and 46 minutes into the flight of Atlantis on the Atlas 1 mission. We're about 42 or 43 minutes away from waking the red team aboard the vehicle. The red team consists of mission specialist Dave Leestma and Mike Foale and payload specialist Byron Lichtenberg. That team will be awakened again in about 43 minutes, and we'll take handover for about an hour, hour and a half with the blue team. The blue team has been on station since just before launch. That consists of Charlie Bolden, Brian Duffy, Kathy Sullivan, and Dirk Frimout. Brian Duffy radioed down just a few minutes ago that he was ready to activate the SSBUV instrument. That's an experiment that's located in the forward right-hand part of the payload bay, mounted inside 2 gas or getaway special canisters that are mounted on the side wall of the payload bay. And the SSBUV, which stands for Shuttle Solar Backscatter Ultraviolet experiment, measures atmospheric ozone levels and compares data it takes with data collected by NOAA satellites and the NASA Nimbus 7 satellite. And all of that data is collected and used to calibrate the instruments.
Go ahead, Kathy.
Okay, Sonny, once again we have an improper stow not locked on API. And this time we once again have a lock number of 0. We do have a rigid stow light on, and we do have a primary servo fault light on. The shutter is closed, and API is down at a co-LNAS of 90.7 and 89.8.
Okay, copy that, Kathy, and we'll look at it and get back to you in just a minute.
Huntsville PS1 for API. Bring it in the logs again. We got the primary fault light on again. Do you want us to stow it to stop it therefore, or just to wait till you have information?
Stand by, Dirk.
Huntsville PS1 for API. A briefing for what I did for this FO. I started a little bit late because of the previous problem to perform this FO. The setup went correctly. When I switched on the high voltage with, I saw the continuous camera, that was with filter 000, but I got nothing with the filtered camera. So I tried another high voltage setting from 1 to 2, and was still nothing with the filtered camera. Then I went to the second filter. There I did integration, and I went up to 5, 6, and then came back to 4 for the this calibration. Then I went to the next filter, 7320, and we just have a little bit of information and was recorded, so but for surely 4320 should have to be done as well. But there I saw pictures of the continuous camera and of the filtered camera.
Dirk, could you repeat the high voltage on the third filter?
Yes, I went up till factor 6 for the high voltage, but then it seemed that I saw quite some noise and stars, and I decided to go back to 4. I would think that 4 would be a better setting for this filter 7620 than higher up.
Okay. What was your integration number of frames on that, Dirk, on 7620?
According to the NOM 35, I had 256 frames for the 7620 filter. And I have 128 frames for 7320. I had 1 frame for the filter 0000.
Okay, we copy that. And were you able to do any of the other filters?
No, I was just doing this second filter. When we got close to sunrise, the Bay Area started to be bright, and I decided to switch off the high voltage and go to the stow position.
Okay, we copy that, and stand by for the some words on the stow situation.
As payload specialist Dirk Frimout relays information related to one of the
And Atlas
experiments.
Huntsville for Dirk.
Go ahead, Rick.
Okay, Dirk, what the API folks would like for you to do is MAL 3.1 on page MAL-4, and presumably you'll go down through block 5 as we did last time. They would like, if you can, in block 5 when you drive the locks, to try to time the amount of time it takes to until you get a lock light on or a 7 lock indication in block 5.
Okay, I copy. I will walk through to this procedure MAL-4. Step 1, block 1, camera high voltage is inhibited. Servo motor load ISO rigid stow light is on. Lock slide is not on. And I'm in step 5 now. I will go to the locking of the manual locking. Three, two, one. Switch. It took 3 seconds. Took 3 seconds to get the lock light off.
Okay, we copy. 3 seconds to get a lock light on.
Affirmative.
And Dirk, do you show a 7 at this point on the display?
Configuration I have now, we have the primary power light on, the locks light on, the rigid stow light on, shutter close light on, and primary hold light on.
Okay, we copy that.
As payload specialist Dirk Frimout continues troubleshooting one of the experiments on the Atlas payload here in Mission Control, the Orbit 3 team has entered the room and is preparing to take their handover from their Orbit 2 team counterparts. The Orbit 3 team is led by Flight Director Linda Ham. That handover will occur over the next hour or so, at which point the Orbit 3 team will take over for the remainder of the evening. We're about a half an hour now away from waking the red team, and the red and blue team will then do about an hour and a half handover. The blue team will go to bed, and the red team will have the operation for the Atlas payload for the next 12 hours or so. Atlantis is currently approaching the equator to begin the 9th orbit, or the 7th orbit of the mission. The view on NASA Select is of Atlantis in its current configuration. The yellow ghost orbiter or outline is a demonstration of the attitude that the orbiter is currently maneuvering to. All aboard Atlantis continues to perform very well. The vehicle has no anomalies at all being tracked here in the flight control room. Again, the Orbit 3 team is now in the room and preparing to take handover from their Orbit 2 team counterpart at 8 hours, 57 minutes mission elapsed time. This is Mission Control Houston.
Huntsville Atlas 1.
Go ahead, Kathy.
Sonny, at the convenience or pleasure of you and the MCC in Houston, we have a camera configured, a camcorder configured on the aft flight deck. We'd be happy to power it on and give you aft flight deck video.
Copy that, and thank you for the offering.
And Houston Atlantis, for the Incos, Jeff, just a reminder, we'll be camcorder only in the cabin, and we've got a camcorder set up on the flight deck monitor. Whenever you guys would like it, we'll power it on.
Okay, copy that. Let me check when we'll be ready to take that.
Houston Atlantis, Jeff Rinko.
Go ahead, Charlie.
Yeah, we just got an unenunciated S-76 comm. Checking the spec, we saw nothing, so we think it was something that was just intermittent.
Charlie, we think it could be an async problem on the camera if you were working it. We'll take a look at that.
Okay, Jeff, we copy that, and I have the SSBUV activation times for you if you're ready to copy.
Okay, Brian, we're ready.
Okay, relay 00 is taken from latent to hot at 8 hours, 54 minutes, 0 seconds. And relay 01 was taken to hot at 58 minutes and 20 seconds.
Okay, Brian, we copy that, and you should be coming up on your call out in your flight plan on panel A12 to take the APU, heater, gas generator, fuel switches to A auto. We're tracking a problem on APU 1 heater. We'd like you to only take 2 and 3 to A auto.
Okay, and Charlie's over there, and we'll go ahead and get that now.
Okay, and a heads up, we're not going to be in coverage to take your camcorder until we get onto Tidris East, so we'll give you a call when we're ready for it.
Okay, we copy that. You just let us know, Jeff. Quick question about A12. Is that only 2 and 3 for both the gas generator fuel and the tank fuel water systems, or just the GG fuel?
Charlie, the only change is to the GG fuel switches, so you'll take 2 and 3 to A auto on the GG fuel.
Okay, thank you very much.
Atlas Huntsville, CIC handover is complete, and Dave will be with you for about the next 8 hours.
Okay, Sonny, it's been a real pleasure starting a great flight with you folks. Thanks for all your hard work getting us ready to be up here.
Thank you and Dirk and the entire crew. It's been a good day.
You bet it has.
Atlantis, Houston, just wanted to let you know that we're getting good data for SSBUV, and we've sent you 4 tags messages, but we may have had some dropouts in the 4th message, and we'd like you to take a look at them.
Okay, Jeff, we copy good SSBUV data on the ground, and we'll go look for tags messages.
Atlas 1, Huntsville, with a request for some info on FO start times on the Star Cal.
Standby 1, Scotty.
Yes, greetings. About what time did we...
Scott, it's Dave, it's PS1 here. When I started, it was 4, it was 8:43 minutes when I started, and we were still going through this procedure with this fault message, primary fault light on. So first thing I did was resetting rebooting the depth, and then I pushed the fault reset switch, continued to bringing it out of the locks and opening the shutter and bringing it out of the locks.
Copy that, Dirk. I understand we had push...
I lost quite some time when I had the first setting with the filter 000, and I tried to get something on the filtered camera, and I could not get something. So then I went to the next filter.
Copy that, Dirk. What we're trying to figure out is how far back to rewind the tape. We only have about 10 minutes that we can dump the tape in, and just wanted to know about when we actually started, getting the data we really wanted.
The useful data was the data taken close to till about 2 minutes for sunrise. Then I switched off the high voltage.
Copy that, Dirk. That'll give us enough to figure out where to do our take. Thanks.
Standby, Huntsville PS1. The time that I gave for switching on ABI was wrong. It was not 8:43. It was earlier. I think I started very close to right on time. It was between 8:20 and 8:30.
Copy that, Dirk. About what time did you start the vidder?
Can you repeat, Steve?
Approximately what time did you start the VITR?
Can you repeat, Dave, what is the time that you are asking for?
Yes, Dirk. Request the time you started the VITR.
I asked Kathy to start the recorder, and that was the moment that I was ready to, when I switched it on the high voltage. So it is estimated around 8:30. But I did take note of it. Next time I will take note of the time when we start the VITR.
No problem, Dirk. We've got enough to figure out what we need for the data dump.
This is Space Lab Operations Huntsville. Conversation between Crew Interface Coordinator Dave Scott and Payload Specialist Dirk Frimout about data that was recorded on one of the video instrumentation
Atlantis,
tape
Houston,
recorders.
We're going to begin the auto purge of all 3 fuel cells.
Copy, Houston.
The Atmospheric Emissions Photometric Imaging Experiment team looking for the time that the video instrumentation tape recorder was turned on during the last operation of their experiment, which was a star calibration. The data recorded during that run will be dumped to the ground operation science team here in Huntsville. We expect to receive video play of that data that was recorded earlier from the photometric imaging experiment during a star calibration run. During that run, the focus setting is determined by testing the instrument. Although the experiment is tested on the ground prior to flight, it's important to retest the instrument in space, checking for good sharp focus with different
Houston,
filters.
With an update to the Serax message, which is message 1 from the teleprinter.
Okay, Jeff, go ahead.
Okay, on line 12, we'd like you to change the mirror frequencies to C9/B11.
Okay, we understand that mirror is now C9/B11.
That's affirmative.
Thank you. Huntsville PS1 for happy.
Go ahead, Dirk.
Rick, do you still want the API running? It's still with the instrument power on? Or can we shut it down?
Stand by, Dirk. Atlas Huntsville for Dirk.
Go ahead.
Dirk, the API folks would like for you to go ahead and complete the power down. I guess you're in the locks at this point, and you ought to go ahead and close out the run.
We are in the locks. I can confirm that we are locked. The lock light is on. So the only error that we have for the moment is the primary fault light that is on. And I copy that I can shut down the instrument.
That's affirmative.
This is Space Lab Operations Huntsville. In the Science Operations area, the science team for the Atmospheric Emissions Photometric Imaging Experiment, waiting downlink of data that was previously recorded on board Atlantis on one of the video instrumentation tape recorders. That experiment consists of a low light level television and a photometer instrument. The instrument is designed to observe faint optical emissions from natural and artificially induced phenomena in the upper atmosphere.
Huntsville PS1.
Go ahead, Dirk.
Huntsville PS1.
Go ahead, Dirk.
Rick, we are creating these messages because we want to set the level of the alarm. So don't worry about the messages that are coming through now. Memory management.
We copy that.
Atlantis, Houston for Charlie.
Good, Jeff.
Just wanted to let you know that the Orbit 2 team is knocking off for the day, handing over to Orbit 3. We appreciate all the good work.
All right, you guys did a super job. And look forward to talking to you tomorrow. Houston, Atlantis.
Go ahead.
Yeah, we're wondering if it'd be okay for us to deactivate the teleprinter.
Stand by. Atlantis, Houston for Brian, you have a go to shut down the teleprinter.
Okay, Jim, we copy that, and good afternoon.
Good afternoon to y'all.